Okay, now let's look at continuity of functions, all right? Not just at a point. So our checklist determined if it was at a specific point. But if I look at continuity and overall general functions, then we go back to what we already know. Check out this example 3. If I want to find all values for which the function is continuous, find all values. Oh, that looks terrible. Oh my goodness, that's no better. Oh, you guys. Find all values where the function is continuous. I heard that last video and I felt like I was banging on my iPad with my Apple Pencil here. So I'm trying to lighten up the load a little. Hopefully it's not blowing your eardrums out with clickety click, click, click. All right, I'll try. Here I have f of x is equal to x over x squared minus 7x plus 12. Now I want to determine where this is continuous. Now think back to algebra, right? What do we know here? Well, how do we know that this function is continuous? Like, what are the issues that can be associated with that? Yeah, 0 in the denominator, right? Nailed it. So what I'm doing is I'm going to I'm going to factor the denominator of this function. Plus in the back, so I know my signs are the same, and 3 and 4 will do the trick, right? X minus 3 and x minus 4. Can I cancel those out? No, that would still not make it continuous, right? A whole is still not continuous. It has limits, but it's still not continuous. Okay. So the issue that we come up with is the fact that I have, let me scoot it up just a little bit, is the fact that I have x cannot equal 3 and x cannot equal 4. So this is for, oh my, for all values of x except where x is equal to 3 and 4. Right? Okay. All right. Set notation. I was looking here in the book real quick. I don't know if he uses set notation, which I don't know why not, but you could also use set notation and say all x values such that x does not equal 3 or 4. I mean, however you want to say that, but that works. All right? Okay, so you don't have to do a limit there because I'm just looking and saying what is not continuous. There's a difference between just finding continuity all by itself and finding the limit associated with it. And sometimes all we want to do is just find a limit. So what if I have something like this? Let me change colors again. Here's example 4. I want to find the limit of this function. Evaluate the limit. So I'm taking the limit as x approaches 0 of x to the 4th minus 2x plus 2 over x to the 6th plus 2x to the 4th plus 1 to the 10th. Now remember your limit laws, right? You can take the limit of that inside function there. What is our go-to method for limits? Plug it in, right? Plug it in. No matter what it looks like. It doesn't matter what it looks like. Your go-to method is to plug that in. So let's do it right now. And remember, you take, as I plug it in, then you lose the limit notation because you're performing that operation. If I want to find where the limit as x approaches 0 exists, then I plug that value in, and that is my operation. So I have 0 to the 4th minus 2 times 0 plus 2 over 0 to the 6th plus 2 times 0 to the 4th plus 1. All of that is to the 10th. Well, obviously, those go, those go. So I'm left with 2 to the 10th. and that is my value. Plug it in. If you ever want to find a limit, plug it in. That's literally all you have to do. All right? When you have an issue, when you plug it in, that's when you do extra work. You either factor, you reduce. We'll learn something called L'Hopital in chapter 4. But there's other ways to solve a limit, but the very first go-to method is always plug it in. I would accept an answer like 2 to the 10th. I'm looking in the book. And this is actually 1024. I don't expect you to find that. You don't have a calculator. 2 to the 10th, I'm not messing with that. Right? So, you're good. Oops, out of room there. So let's keep on this going over here. Oh, we're not quite to example 6 yet. Let me scoot this down a tad. Okay. Here's example 5. Oops. I again want to find the limits. If I find the limit. If I take the limit as x approaches -1 of the square root of 2x squared minus 1, what do? Yes. Plug it in, right? Are you feeling like we keep beating this exact same drum over and over again? Because we are. Because that's the way it works. Plug it in. So, this is the square root of 2 times -1 squared minus 1. So, a negative number squared is positive. So, it's 2 times 1 is 2. 2 minus 1 is 1. Square root of 1 is 1. Plug it in. Literally, I cannot impress this upon you enough. Don't make this harder than it is. All you have to do is plug it in. What if I have the limit as x approaches 2 of the cosine of x squared minus 4 over x minus 2? What happens whenever I plug this in? Oops. Oh, goodness sakes. Yes, good job. Can I have a 0 in the denominator? Negatory, good buddy. Okay, when you come across an issue, that's when you do work. Well, what are you seeing is happening right here? Yes, that's a rational expression you can simplify. I have not taken the limit yet. So, x minus 2, x plus 2 over x minus 2. You have to keep writing that limit notation until you take the actual limit. Now, I'm simplifying that. I'm going to squeeze this up a little bit here. I actually have the limit as x approaches 2 of the cosine here of x plus 2. Now when I plug that in, let me get this little feller back out of the way again. Now when I plug that in, I get the cosine of 2 plus 2, which is simply the cosine of 4. The cosine of 4 is not something that we know that is common, so literally just leave it as a cosine of 4. All right, I'm okay with leaving it like that. You could plug it into your calculator, that's fine. On other things beyond this class, like if you have this in a physics class or something, you'll obviously be using your calculator for that. But we're not going to, just leave it as a cosine of 4. All right? Okay. Now, I think I'm going to stop this video right here, and then we're going to pick it up on the next